In this paper, we present a method to create word as image illustration automatically.
Welcome to Talking Papers, the podcast where we talk about papers and let the papers do the talking. We host early career academics and PhD students to share their cutting-edge research in computer vision, machine learning, and everything in between. I'm your host, Itzik Ben Shabbat, a researcher by day and podcaster by night. Let's get started. Hello and welcome to Talking Papers, the podcast where we talk about papers and let the papers do the talking. Today we will be talking about the paper Word as Image for Semantic Typography. This paper was published in SIGGRAPH 2023 and received the Honorable Mention Award. I'm happy to host the first author of the paper, Shir Iluz. Hello and welcome to the podcast. Can you introduce yourself?
Yes, so thank you for inviting me. My name is Shir Iluz. I'm a master's student at Tel Aviv University under the supervision of Professor Daniel Cohen-Or and Professor Ariel Shamir.
And who are the co-authors of the paper?
So my colleague Yael Winker is an equal contributor for this paper. And we also have Amir Ertz, Daniel Berio, Daniel Cohen-Or, and Ariel Shamir, who contribute significantly as well.
All right, amazing. So in a TLDR kind of format, 2-3 sentences, what is this paper about?
So this paper presents a method that creates word as image illustration automatically. Word as image means that we take words and then turn them into a visual representation of their meaning while preserving the ability to read them.
Right. So basically your input is a word, right? And your output is that word only with some letters in shapes that represent the semantic meaning of that word, right?
Yeah.
Okay, so now let's dive into the introduction. What problem is this paper addressing?
Okay, so semantic typography uses typography to visually highlight the meaning of the text. It can be done with the size of the letters, with the position of the letters, color, style of the font. One of the most challenging techniques in this field is to create word as image. In this case, the meaning of the word is illustrated only with the graphical elements of the letters. Only use the letters shape. So if we break down this problem, first it requires the ability to understand and depict the characteristic of this word. And then we need to take this characteristic of this word and it needs to be simple, it needs to be visually appealing, and of course presented clearly while preserving readability of the words. It takes a lot of creativity and design skills to integrate the chosen visual concept into the shape of the words.
Which brings me to the question, why is it an important problem to solve? So who needs this kind of semantic typography? Where is it used?
Okay, so this technique and this innovation of word as image is potentially to be used in many domains, such as graphic design, advertising, branding. It could be lead to new forms of creativity, and it's very applicable.
Yeah, actually, I can totally see how this fits into any designer's workflow when they're designing, let's say, a logo or something like that. It's totally exactly. Plug and play.
Mm-hmm.
Now tell me, please, so what are the main challenges?
So until recently, it was practically impossible to automatically create word as image using the computers. To achieve this task, our paper describes novel algorithm that based on recent developments of in deep learning and also utilize the availability of huge models that combine language and visual understanding. So it's the first time to do it. And it opened the possibility for the use of large vision language models to use in semantic typography. This is the first time to do it. And also, our method is a vector-based representation of the letters, which allows to rasterize them in any size and to add color and texture if we needed.
Yeah, right. So just to make the raster and vector representation clear to people that don't play with fonts all day, right? So raster representation, that means basically pixels, right? We have little squares that we fill with black or white to make the font work. And that's fine as long as you don't need to scale the font up or down too much. It works okay. But once you start scaling, then things start to be visually displeasing because they look either blocky or something like that. So there's the vector representation that basically you have some equation, control points, some splines that represent the font, and then you can scale it up or down as much as you want, and you don't have any of these kind of effects.
Yes, exactly.
Okay, so moving on to the related work section. So before reading this paper, which one or two papers should people read?
Existing method in the field of textilization usually operate in the raster domain, in the image pixel domain, and use existing icons that are available in the internet. So the paper I really recommend to read for the technical aspects of our paper, our method, is the vector fusion. With the existing of a strong pre-trained large text image models, it really desirable to utilize it for another domain to generate tasks behind the raster images. So we have the Dream Fusion that was the first to propose a way to use the diffusion loss to optimize parameter of a NERF model, and they did it for text to 3D generation. They actually defined the SDS loss, that it used the gradients of the original diffusion losses. And this loss allows to optimize samples from an arbitrary parameter space, not exactly the raster images, as long as we can map back to image differentiability. So for this use, we use the DFG, the differentiable renderer. And during training, the gradients are break propagated to the parameters of our domain to fit to the text prompt. So Vector Fusion was the first one to do it into the task of text to SVG generation. And we found it very useful to our approach. So this is a really important paper to read before our...
Right. So it's time to get down to the approach. So tell me, how did you do it?
Okay. So given a string word, our method is applied to every letter separately. We work on each letter separately. Let's begin by defining the parameter representation of our problem. So we take the letters, the font. We extract the outline of each letter and convert it to a set of cubic bezier curves. So each bezier curve is with 4 control points, and what we actually optimize is the location of these control points in the space. And after this, we utilize the pre-trained stable diffusion model. So this is so we use it to connect between text and images, and we use the SDS loss, as I mentioned before, to encourage the appearance of the letter to reflect the semantic concept. And since we use stable diffusion, it was pre-trained on raster images, we need a differentiable rasterizer. We use DiffVG. It allows us to break propagate gradients from the raster-based loss to the shape parameters. To preserve the shape of the original letter and to ensure legibility of the word, we utilize 2 additional loss functions. So the first loss is regulate the shape modification by constructing the deformation to be as conformal as possible over the triangulation of the letter's shape. It's basically L2 distance between the corresponding angles of the letters before and after the reshape. And the second loss is preserve the local tone and the structure of the letter. We do it by comparing the low-pass filter of the resulting rasterized letter to the original one. So it's L2 distance between the blurred raster letters before and after the reshaping. And these are the main objective functions that maintain the style of the font and the readability of the letters and the word as well.
This was a bit much. Let me just quickly recap what I understand, okay? And tell me if I'm right or wrong. So the input is text, right? It's a word. Now, then you want to change each individual word to represent the semantic meaning of that word. So let's say you have the word cat. You want each letter to now be distorted in some way to show a cat.
Yeah.
Then in order to do that, the first step is to break down these letters into individual control points, right? You represent that as bezier curves, and in the paper I saw that some letters you can represent with very few bezier, so with very few control points, so you kind of add more control points and you have a nice ablation study on the control point. But basically you have control points as input, then you feed that into your pipeline, and basically a diffusion model is what kind of gives you the semantic meaning for this distortion. The problem is that it kind of over distorts it in such a way that it doesn't reflect the original letter. So you kind of add these two new components, two new loss functions that try to maintain the readability of the letter, right? One of them is this as conformal as possible, right? You do a triangulation, you try to kind of minimize that. And the other one is the filter-based one, where you kind of take the input letter and the output letter, you blur them out, and you want to say, okay, these kind of two should be like very close to each other. Otherwise, this thing is totally distorted.
Yes, exactly. I just can add that the weight between the three objective functions is really important. It's very, very sensitive. We need to find the right balance between all of them so we can actually make an impact and to change the word, to change the letter to the semantic concept and still maintain the readability. And this is also a hyperparameter, so everyone can choose whatever they like, and because this is a kind of a field that anyone can love something else.
Right. So they can use it to customize the output that they want, right? They can use it as these kind of control knobs, right? I want it more semantically meaningful, less readable. I want it more readable, less semantically meaningful, right? These are these kind of control things you can play around with, and you can get like different results and do all sorts of different things, right? In the results of the paper, I saw that you don't always change all the letters, because if you change all the letters, then it's sometimes hard to make out the word. But then if you change like only the few ones that are very kind of distinct, then that kind of brings everything up and you're like, oh, wow, this is an amazing result.
Yeah.
Which actually is a nice bridge to the results section of the paper, right? So how do you even evaluate this kind of method?
So we define three objectives for the efficiency of the results. It should be visually captured to give a semantic concept. It should maintain readability, and it should preserve the original font style. So to evaluate this, we conduct a user study to measure how we succeeded in this method. So the user study showed to people letters in a shape of a semantic concept and another fonts that can relate it to. And the people need to choose what the semantic concept, what the font that is connect to, and what's the letter behind it. And we did it to results from our method, and also for results using only the SDS loss, so only the semantic change process. And of course, the result is as we expected. If it was only the SDS loss, so the semantic concept was very recognizable, and people see the actual what we mean, but they couldn't read the letter, and they couldn't understand the style of the font. And if we do it with our method, so the results show that the level of concept recognition are very well, and the letter legibility were very high, and also the style matching of the letters. More of that, we also tested our algorithm according to a baseline that we compared to. We define baseline based on large popular text-to-image models. We used Stable Diffusion, we use SD-Edit, DALL-E 2, and Clip Draw. And in the paper, you can see that each one of the method missing something. Some of them couldn't make any legible text. Some of them couldn't put enough a semantic concept, and some of them didn't save the font style at all. And so you can see that our method is the best, of course, between those methods.
Yeah, I think like the interesting part about the results section of this work is that it's not your traditional bold numbers table that you compare to existing method. It's like a really kind of, it's launching this new direction of doing this kind of new task in some way, right? And the best way to evaluate it is, I think, is the user study, right? Because it's all subjective, right? Is it aesthetically pleasing? Is it readable? That really depends on the person that's looking at it, right? Some people will pick up things that other people won't. And I really like that part of the experiment section. Were there any kind of fail cases that you've encountered?
Of course. Most of our fail cases is where the semantic meaning of the word is like ambiguous or difficult to visualize. In some cases, the deformation of the letters may not convey enough the semantic concept. In other cases, the letters convey the semantic concept too much, and the letter was not readability. So this is the kind of problem we address to.
And were there any unexpected findings? Like, has something happened that you didn't expect it to?
I think that we show in the paper that this method can work on a Chinese language. And I think it was really amazing that it can work on every language. I also saw someone from our community that he utilized our code to do it to Arabic language. So it's really can be modified to any language. And I think this is like it worked on Chinese, so I think it can work on any other language.
Yeah, wow, that's really interesting. Fine. So moving on to the conclusions and future work section of the paper. So how do you see the impact of the paper going forward? And were there any interesting follow-up works?
The paper has received significant attention in the community of computer graphics and also among designers. Like Twitter is blowing up about this concept. And I think overall the paper made a significant contribution to the field of typography. It's something very creative and thinking out of the box about this problem. And I think and I hope that it will lead to new research in the field. There are some papers that already quote us. The first one was Diffusion. I will let you to quote it. It basically uses our way of thinking and add color and more stuff to this problem, and it's really nice. Our paper, I think it's put unique tools. It's like very applicable, and it can put help to designers to generate unique and personalized words image illustration. As I said before, they can use it in different styles and different balance between the semantic concept and the readability, and they can choose any semantic concept and any text. You don't need to make the semantic concept as the same text you put. Like you can put your name Itzik, and you can use a semantic concept of a podcast, and to choose a one letter, and it can change it. Anyone can try it. We have demo in Hugging Face, so it's public for all, and we can it work for many semantic concept and for a lot of font styles. So it's really a robustness method.
Yeah, and I think the nice thing about this paper is that it kind of fits into this new line of work of creativity, right? You're basically providing this very cool new tool that people are going to change their design workflow that, usually designers, they used to, take the font and do it all manually and like figure out the concept or how to change the letters on their own. But now you have this new amazing method. You can just run it, like even if you're not using the output as is, but it's a nice kind of first draft that you can use, or you can use it as is. The results are good enough, in my opinion. I'm no designer though. And I think the fact that there is this online demo that you can use is super useful for the community to kind of explore the different options and kind of see how the results work. I'm going to use it like right away and try it on the podcast title.
Right.
See how that works. Okay, so this brings us to my favorite part of the podcast. What did reviewer 2 say? Please share some insightful comments in the review section.
So actually, all of the reviewers were very excited about this approach and these amazing results, because we supply a lot of results in the supplemental materials. And the reviewer 2 found it a very interesting paper and fun to read. He really enjoyed it, and I think it is quite interesting work. And he proposed it for the general track for SIGGRAPH. And the one thing that was missed, in his opinion, is the more examples of the limited of our method. You can see it by the many results that some of them is like, as I said before, but he wants us to emphasize it more. So we add it in the next version of the paper.
Right. So the reviewer wanted to see where does it fail, right? Because
it's too good
Yeah. And I think it's a valid point, right? Because a lot of times, I'm not talking specifically about your paper, but generally in many papers, you see results, right? When they're so visually pleasing, you're kind of wondering, is this cherry picked or is this like really works universally, right? And in the absence of these kind of, extended data set, when you can benchmark everything into a table, which you can't really do in this kind of work, then I totally get what he's saying. Like, show us where it fails. We want to see the failure cases. And I think overall that what makes the work better, right? You show the good cases and the bad cases, and like people can decide for themselves, right?
Yeah.
All right, excellent. Anything else you want to add before we wrap up?
There is a website you can go in and try the code and the demo by yourself, and can see and make your creativity come to life with this word as image, and enjoy.
Yes, thank you very much for providing this kind of useful tool for the community that they can just go and use, this demo and code. This is super useful, and I always kind of have a warm place in my heart for these kind of works that put the extra effort into getting these kind of things up and running for the community to use. So thank you for that. And it's time to wrap up. So Shir, thank you very much for being a part of the podcast. And until next time, let your papers do the talking.
Bye.
Thank you for listening. That's it for this episode of Talking Papers. Please subscribe to the podcast feed on your favorite podcast app. All links are available in this episode description and on the Talking Papers website. If you would like to be a guest on the podcast, sponsor it, or just share your thoughts with us, feel free to email talking.papers.podcast@gmail.com. Be sure to tune in every week for the latest episodes. And until then, let your papers do the talking.